Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of forces and fields, which is the very important topic that is the Milklean's all drop experiment. So in this topic we will learn about the plates more, the parallel plates more, and how that all drop experiment works, and how the elementary charge can be made. Basically, the elementary charge which we do the divided by E has the value of 1.610 to minus 19 coulombs. How this can be made, and what is that all drop experiment? How can this work by the Milkleans? How can they do that? So this is the kind of the diagram for this. This is the experiment of this, and you get the oftenly you get the questions related to that questions. How that type of question you get? So we will discuss today. So firstly, what is that experiment? Uh, in this experiment, Berkeley and the French used an atomizer to spare into tiny droplets of oil on the top of the closed vessel containing two parallel metal plates, and there were holes in the top plate which oil drops would pass through into the lower part of the vessel. So maybe what they are doing, like they put the that atomizer and they put the droplets in. You can see they put the droplets in to the that spray at the closed vessel. This vessel is almost that closed, and you can see that all droplets are going like this, and they're doing on the parallel plates. This is first parallel plate, this is second parallel plate, and they're doing on there, and the one drop comes to that parallel plate and pass to parallel plate and those to another parallel plate. So basically what they're doing, like as the all droplets were usually spherical in shape, the mass of the each droplet would be calculated from the diameter of the drop and the density of the earth. So you know that they are spherically shaped, all droplets, and their diameter can be measured by the mass they have and with the diameter they then measure with that. By connecting the high voltage battery to two metal plates, Milklean could absorb the motion of the all droplets in a uniform electric field and determine the electric force acting on each drop, thus allowing him to determine the change on the drop. So what they do, they calculate the voltage with this. So you can see they created the voltage over there with that two parallel plates, and what they observed that with the telescope eye space, that the all droplets, that's how they go, they saw that they are uniform electric field. They have a uniform electric field, they have like a straight line motion. Like you can see clearly, you can see this is a straight line motion that droplets are doing the straight when they pass through that parallel plate to goes to that parallel plate. So that's all they do, and to determine what they want, to determine the charge of that drop. Basically, they want the charge of that particular drop. After that, you have the diagram over there now. So Milklead varied the size of the oil drops and found that the charge has either the 1.6 raised to power minus 19 coulombs or an integer which is multiple of this value. So the approximately they like find out the charge of this, which is 1% times minus 90, or they say that this is the higher and this is the integer of the multiple of this value. Maybe they're not like a very accurate manner now at that time. Belker reasons that the smallest possible charge that a drop can have is the charge required by gaining or losing an electron. When they gain, when they lose, that particular charge, the smallest possible charge they get, that is the accurate charge we get. So they conclude that charge of the electron has minus 1% 10 raised to minus 90 coulombs. So they read the negative value now. So after that, on May 20th, 2019, that's the University met with base units for redefined, where they redefine the fundamental constants of the nature will randomize the z value with no certainty. So elementary charge redefined to have a z value of this. So that the big value of this. So that big value is not very like we can memorize it. We have to see like what's that value. This very long value. So they, for the purposes of the calculation, to precise that value, they precise that value to this, which is 1% into 10 to minus 19 coulombs. So this is like the value which Mengele resumed when they do that experiment. When they do that whole that experiment, they resume that value. So that's value with that, which is 1% that is minus 19, and the precise enough which the value can be, we can use that in the calculations. So this value is called the elementary charge, and we all know that this is denoted by the E. So that's how the elementary charge can be made. And after that, the mass of the electron that has to be made. So we can see that mass of electron is 9.11 10 raised to power minus 31 kgs. So that the mass of electron can also be made after that. So these both values are on the data sheet. So don't worry to memorize it as I told you what to do. So this experiment is like, we just know this experiment because we're doing the sums related to this. You can see when we do that, there's like we see that there's a straight line motion which is determined, which will like form the uniform electric field. So the uniform electric field, and you can see there's a gravity over there. The droplets play over there, and they go like drop by drop over the ground, which like goes to a gravity. Because of gravity they goes down. So that was the relationship between that both the things, electric field and the magnetic and the gravitational force. So we will do that type of questions. Like we have the one question over there. So what do we have to find? So we have a 2.50 by 13 kg all drop accelerates upward at 2.80 meter per second square. Have placed between the two horizontal parallel plates and have a distance of the part of 0.340 part, where potential difference between two places is 890 volt. So we determine the magnitude of the charge on the top. So basically we have to find the q. We have the acceleration over there. So as I told you that there is a something is electric field and the gravitational force when we're talking about the oil drop, anything related to the oil drop experiment. So this means if we made the free body diagram over there, we can see if there is oil drop. So electric field goes up, and the magnetic field, the gravity goes down always. You can see the gravitation force always go down, and the electric field always goes up against that thing. So if we can relate it to this question, so we have net force which is equal to Fe plus Fg. That whole net force is equal to the electric force plus the gravitational force. And the net force, you know, this is the mass into acceleration. F is equal to Q times electric field plus this is the mass and the gravitation. So we have to find the Q. So the Q electric field, this is equal to Ma minus Fg. So from here you can see Q and you can take M as common over there. So this is that divided by what? Divided by electric field. So now you have all the things except the electric field. To find the electric field, you know our formula is delta V upon delta D, and you have the both value. So this is delta V, 890 volts, and you have a delta D of 0.340 meters. When you calculate this, you get about 7.64 volt meter. Our mass of this, so 2.50 10 raised to minus 13 kgs, and we have acceleration of 2.80 meter per second squared, minus gravitational force is 9.81 meter per second squared, and this goes against the gravity, so it's always rotated negatively in this case. So this is in negative, and we have to divide this by 261.64 volt per meter. So this is volt per meter, and you have to find that Q. When you calculate this, we get about 1.204 into 10 raised to power minus 15 coulombs. And you want 3 say this, so it's 1.20 into 10 raised to power minus 15 coulombs. So that's how you can find anything if you want. So that's how this formula works. We have to do that body diagram, free body diagram with this. So Fe plus Fg is a relationship we're doing this. So we will do one more question related to this, which is like related to the perpendicular to surface when we do the x and y thing, where it's a uniform motion, accelerated motion. So with that question, that thing, it says the two horizontal plates are separated by a distance of 16.0 centimeters. As you can see, this 12 plus 4 is 16, so its two parallel plates are separated by this. The oil drop is directed horizontally between the plates as shown below, with the mass of 7.5 into 10 raised to minus 5 kgs, charge of positive 1.75 microcoulombs. The oil drop has a speed of 0.1 2 meter per second as it enters between the plates. The potential difference across the plates is 20.0 volts to determine the horizontal distance traveled by the oil, drop in region between the horizontal plates, and sketch engineer to how to diagram the path that a oil droplet will follow. So basically what we have to find the horizontal distance at the dx. So here's the talking about the horizontal distances and the plates. So basically what they do, so they said that they move like this. The oil droplet moves from here, and what they do as at some height. So this height is that vertical height. So this is your delta dy, and what that distance they go like they move inwards and they do over there because they go towards the gravity. So from here to here there is a term delta dx. So that delta dx we have to find. So basically what then we do that we have over there, we have electric field, we have electric force over there, and we have a magnetic force over there. So when we're doing like this type of questions, firstly we have the horizontal, we have mentioned that the horizontal distance we have a vertical distance. So we have to make the uniform motion accelerated motion. So we have uniform motion x and the y, which is your accelerated motion. We have to find delta dx, delta dy is from there to there, so it's 4.0 centimeters, which is 0.040 meters. For Vx, they traveled with 0.210 meter per second dimension over there. So that's it. And VIF is remains 0 as I told you when we do this. So time is not given to us for the both. So basically we have to find the acceleration first because there's nothing talking about the electric field in this sum because we're doing the oil droplet experiment we do. So in that sense, electric field is not involved. Electric force is involved in this, and the gravitational force is involved in this. So basically, what we have to find the Fe first. To find Fe, so we have Q E. So that Q E we don't have, we have not have like electric field. We have the electric field which is equal to delta V upon delta D. So we have delta V and delta D in this. Delta V and we have delta D. So that two things we have. So we have to, instead of writing the electric field, we write delta V upon delta D. So if Q is positive, which is 1.75 into microcoulomb, the micro has the value of 10 raised to the minus 6. We have delta V of 20.0 volts and divided by 16.0 centimeter, which is 0.106 meters. 0.160 meters. When we calculate this, we get about 2.1875 into 10 raised to power minus 4 newtons. So that is your Fe. Now you also have to find the Fg in this, which is mass into gravitational force. So mass we have given to us, which is 7.5 into 10 raised to power minus 5 kgs. Gravitational force we take as 9.81 meter per second. We take it as positive because we calculating this. And when we find, we get about 7.3575 into 10 raised to power minus 4 newtons. We get Fe and Fg. Now we have to figure out that what is greater. So it clearly says that Fg is greater than Fe. You can clearly saw this. So this means that the oil droplet, if the Fg is bigger, so this means oil droplet goes down towards positive plate. If you don't know that how the droplet goes, I say you directly with that they go positively. But you have to find this first. You have to find the Fe and Fg. If the Fg is greater, so it towards the positive plate. If it is not greater, if Fe is greater, so it goes the negative plate. But there's some like a not that case you have just that case, and that all droplet goes to the positive plate. So now we have to find that dx. So for dx to find, we want that acceleration. Why we want that acceleration? Because of the time. Because ds is equal to vs times t, which we have the time for this. We have vs. First, let me find the acceleration for this. So let's find the acceleration. To find the acceleration, we know now F net is equal to Fe plus Fg. This is mass into mass times acceleration, electric force, and the gravitational force. We have both of this. So this is equal to Fe plus Fg, which is divided by the mass. So Fe we have about now the Fe. Okay. So that Fg goes down. So Fe goes up. This is a free body diagram. So this means Fg goes down, which is the gravity type of thing. And if Fg is greater and it goes down, so Fe goes up. So it goes up, this means this is negative type thing. So you have to take the Fe in negative now. So the negative 2.1875 into 10 raised to power minus 4 newtons plus this is remains in positive, your Fg. We have to divide this by mass. Mass is 7.5 into 10 raised to power minus 5 kgs. So the acceleration is equal to 6.8933 meter per second square. You got this. Why are you calculating this? Because of the time. So for the time, you have now this dy, you know that formula, which is vi by t plus half ay t square. This is 0, so it goes to 0. We have to find the time. So this is 2 times delta dy and divided by the acceleration we find. So that 2 dy is 0.040 meters. Acceleration you find, which is 6.8933 meter per second square, and that whole to the root. So when you calculate this, the root of this, you get 0.1077 seconds. So now all the things are done. That big calculation is all done. Now our focus is to find this one. This is that over there. So we know that delta Vs is equal to delta dx upon time. This is okay. So we have to find delta dx. So this is equal to Vx times t. So Vx you have 0.12 meter per second. Time you find of 0.1077 seconds. So that delta dx is equal to 0.01292 meters. To find this, you want this in, if you want this in centimeter, you have to find that you have to just multiply this by 10. So 0.013 meters. I have to multiply this by 100 centimeter upon 1 meters. This meter cancel. So what do you get? Get about 13.0 centimeters. So this is your answer for the horizontal distance you have to find. And they also want you have to sketch this. So we sketch over there. This. So that's all what you have to show in this type of thing when you asking about the all droplet question with the parallel plates one. And we use the uniform accelerated motion, and but also we use that concept Fe and Fg, which is equal to the addition of that is equal to the net force. So that's all what you have to find. That not like very much work because they all the kinematic equations we doing. So that's the new thing in this, and that acceleration you have already find when we do that t, that vs and ds all are like the same kind of thing. New thing is just the one. So that's all for this lesson. So we're completing the MILLIKAN'S all drop experiment, and also we're completing the electric fields concept. That all the part of the electric fields in this unit we completed now. So the next lesson we'll start with the magnetism now, but before start doing with, we will do some practice questions related to this electric field concept. This is a big concept, and we have many questions like diploma questions and practice questions to do with that. So next we will do practice question, then we'll start with the magnetism. So learning my simple way, EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.